Hello, and we're here for, my goodness, day 8 of December for our Advent calendar. And I think we've seen what we needed of the back, so let's get inside this time. Get inside straight away, I guess. So, door number 8, another small looking one. What have we got? Just get behind the door. And, oh, right, we've got what I think is a potentiometer. So it's a knob you can turn, and I think that is just like the resistor we had yesterday, except by changing the knob, you actually change the value of the resistor. You may notice there's 3 pins, and that's actually because, well, you can kind of treat it as 2 resistors, one between this pin and this pin, one between this pin and this pin, with this wiper changing where the middle one is along a resisting track. So as we turn the wiper, as we turn the dial, change the resistance of those 2 things. I think we're going to build something that makes different noises depending on where the dial is. Another small but mighty component. So, let's see, what have we got for day 8 here? Behind the 8th door you'll find a variable resistor, a trimmer potentiometer, yep, also called a trimmer or a trimpot. And the resistance can be adjusted continuously by turning its axle. So we're going to extend this circuit as shown. Right, let's disconnect the batteries. Oh, I'm disconnecting the... let's put this where you can see me. I'm going to keep my button there because that's kind of handy. And let's put the speaker back where it was. So this resistor now goes across to, well, we just got 1 pin over there, like that. And this trimpot comes in down here. Now they've shown it going into this pin. Oh no, that is that pin, that's okay. So they have accounted for the width of that, that's good. Okay, means I've got to splay the legs of this capacitor a bit more. And pop it in there. Now this is likely, as I mentioned yesterday, the resistor capacitor circuit allow you to change timing. So resistor will limit how much current is going to capacitor, which limits how long capacitor will charge for. And in this case, we'll be changing the resistance, so we'll be able to change the timing, which will then change the frequency we hear. Now, I should be able to use the wire we had from before. It's a bit on the long side. Maybe I'll get a shorter length. Let's get a shorter length of wire and make one just about that size. Okay, actually before I cut the wire, we're going to move this switch across, because they've shown it moved across there, out of the way a bit. Bring that here. And what I'm going to do is measure on the board from there to there, and then leave about, I don't know, 5mm on each end for actually taking off the insulation. So it would be about there to here. So there we go. And this is where you do want kinks, because that will be what will get it into shape on the breadboard later anyway. So about there with the cut there. So we'll cut that. And remembering what we learned the other day, might be easier to come in around the back. No, it doesn't really change it. Oh well. Okay. Got one side. See, it's all been out of shape already. It's okay, I have some pliers here to shape it. Okay, both ends are stripped. We'll just straighten it up. There's still really a bit of a a notch there, so maybe I should still go one further insulation step up, I guess. And there we go, that's just right. There's not too much wire, not too little. Okay. Now when we connect this, I'm expecting it to make noise again. Ooh. Oh, what am I missing? So that's on the right pin. That ground is on the right pin. That's in. Oh, what I'm missing is the speaker wasn't actually connected properly. Let's try that. No. Let's get a bit closer. We have our first issue. Now I have... there's our issue. So my slight tinkerings where I added a button. Okay, it's not doing a lot. And there's a point past where it just gives up. Does appear to be getting a bit higher. Well, it's certainly capable of making quite annoying noises. But okay, that kind of works. So it must be going past some limit somewhere. Got it much higher that time. Not entirely sure what the limitation is there, why it won't always go up. Or is that just that this trimpot? I don't know if that's just to do with the way the capacitors are or if there's a problem with the trimpot. Anyway, it definitely works. Now, what it's actually saying here is the more you turn the axle in a clockwise direction, which is what we're finding, the higher the pitch or frequency becomes. And near the right stop where the axle won't turn anymore, the oscillation will end. Well, near, but not at. So it does end quite... I suppose it could go higher, but it doesn't. So, yeah. I wonder if we should dive in and have a quick look at the circuit diagram. So I'm expecting it to be a lot like yesterday's in that we are going to have the same amp here. I'm going to, for convenience, although the chip is the other way up, I'm going to put the plus near the top and the minus near the bottom, because if I remember from yesterday, that minus goes down to ground and do our ground down there, and the positive now goes through. Well, we've got this variable resistor. We've got our capacitor first. Then we've got a variable resistor where one side goes down to ground and the other side goes through our fixed resistor, which then takes to our output. So there's our feedback for our oscillation. That goes through the electrolytic cap to the speaker, and then that goes down to ground, and of course there are your ground and positive lines. That also still has the LED. Should have left myself more room at the top here, huh? So That's okay. This is not needing to be a perfect CAD diagram. It's going to be good enough to get the idea of what's going on. And there's our batteries. And of course I have added, I'm just going to do the switch symbol for this just because I'm not high on space, but it's the same principle. So I've added that. So when we change the potentiometer, that's this component here, just got this arrow to show we can move up and down. And that's moving up and down, I guess, where this capacitor gets fed from, either closer to ground or closer to feedback. And well, I guess as we turn it this way, oh no, we are turning it that way, so I guess we'd be turning it closer to ground when it starts to tail off. So we'd end up getting our feedback from there, through this other resistor, through this other capacitor, through to the op-amp. But I believe that's the circuit we're looking at here. And these three components here now control the timing, control the frequency we're getting. Anyway, I hope you have found that interesting. And the noises are definitely sort of annoying, but they're going to get more interesting throughout the experiments. Oh, that's interesting. I think that's because it's pulled too close to ground. Maybe a resistor down there will help, but maybe I'm jumping the gun there. Okay, hope you've enjoyed this. Hope you can come back for tomorrow's Advent. We'll see what's in the next window for day number 9. And go make stuff and be awesome. Bye!